Good afternoon, everyone. Welcome to the week 6th of this tutorial session of Principles of Communication System. So today we will solve question based on the lecture taken on week 6th. So we'll solve some of the questions on the topics which were taught in the uh, 6th week of this course, Principles of Communication System 1. And also this video will be uploaded on YouTube, and this is recorded and it will be uploaded on YouTube. So if you have any difficulties, you can ask. And you can ask in the comment box on the YouTube as well. So coming to the first question. So the first question is, consider a narrow band frequency modulated FM signal with modulation index beta given as the input to a frequency multiplier by a factor of n. So the modulation index of output wideband FM signal is. So when a frequency multiplier factor of n is there, then the output will be n time beta. So here the correct answer will be the modulation index of the output wideband FM signal is n beta. So this frequency multiplication can be achieved by passing signal through a nonlinear device. Frequency multiplication can be achieved by passing signal ST through nonlinear device. So here, like let's suppose ST is there and a it is passed through a nonlinear device. So let's suppose it is just doing the cube of that signal. So here we are getting A of S cube T. So let's suppose ST is AC cos of 2 pi FCT plus beta sine of 2 pi FMT. So this term is theta of IT. So we can write as AC cos of theta of IT. So after cubing it, what we will get? We will get A dot AC dot cos cube of theta IT. So, and also we know that cos cube theta is equal to cos of 3 theta plus 3 cos theta divided by 4. So here it is multiplied by n. So beta naught is equal to 3 into beta. So here frequency modulated signal at carrier frequency is equal to n into Fc. So modulation index is equal to n into beta. So in this question, the correct answer is option number 1. So this is the correct answer for this question. So we'll move on to the next question, and this video will be also recorded and uploaded on YouTube. So here given the FM signal. So FM signal in this question is given xct is equal to 10 cos 6 pi into 10 to the power of 60 plus 1 by 4 sine 8 into 10 square pi t. So xct is 10 cos 6 pi into 10 to the power of 60 plus 1 by 4 sine 8 into 10 square pi t. So this is given. So now the bandwidth of the FM signal, like using the Carson rule, is 2 beta plus 1 f1. 2 beta plus 1 into fm. So this is the Carson rule. For Carson rule, actually is given by this formula. So now we'll substitute the value. So here beta value is here 1 by 4. So we can write bandwidth is equal to 2 into 1 by 4 plus 1, and the value of FM, what is the value of FM here? That is 400 hertz. So this is equal to 2 into 5 by 4 into 400 hertz. So the value will be 1000 hertz, that is equal to 1 kilohertz. So option C is the correct answer for this question. So now we will move on to the third question. Consider an FM signal with the instantaneous frequency FIT is equal to FC plus KFAM cos 2 pi FM T. So the modulation index beta of the signal is. So the modulation index beta of the FM signal is equal to KF AM divided by FM. So for this question, the correct answer is option number C, that is KF AM by FM. So now we'll move on to the question number 4. So this is a frequency modulated FM signal. I think network issue. So I will just turn off the, just give me a minute. Actually, I'm recording with my laptop device, so their network issue is there. I changed the Wi-Fi, but still this network issue is persisting. Just give me 2 minutes. I will change the browser. Just give me a minute. Now the problem is with the Chrome. So sorry for the internet issue. So now we will solve the question number 4. Just let me check whether recording is going or not. The recording is going on. The question number 4 is a frequency modulated FM signal is described by the equation phi t is equal to 25 into cos of 10 into 10 to the power of 6 pi t plus 10 into cos of 4000 pi t. So this equation is given. We have to find the maximum frequency deviation delta f. So here beta is equal to 10 and fm is equal to 2 kilohertz. So the frequency deviation delta f is equal to beta into fm. So this is the frequency deviation formula for the fm signal. So now delta f is equal to beta into fm. So beta is 10, fm is 2 kilohertz. So delta f is equal to 20 kilohertz. So the option B is the correct answer for this question. A given phase modulated signal, now moving on to the next question, has a maximum frequency deviation of 25 Hz for an input sinusoid of unit impulse AM is equal to 1. So this is unit amplitude, so AM is equal to 1 and the maximum frequency deviation of 25 Hz is given and the frequency of 150 Hz is given for the input sinusoid which is having a amplitude 1. So determine the required frequency multiplication factor to produce a maximum frequency deviation of 25 kHz when the input sinusoid has unit amplitude and frequency of 300 Hz. So in this given phase modulated signal has a maximum frequency deviation. So maximum frequency deviation, that is delta f, is given as 25 Hz. That is also can be written as kpam into fm. So kpam is 1 and fm is given as 150 Hz. So here the input sinusoid has unit amplitude and frequency of 300 Hz. And it is given the fm value as 150 Hz. So now kp into 1 into 150 is equal to 25. Because it is given the maximum frequency deviation of 25 Hz for the unit impulse of unit amplitude and frequency fm is equal to 150 Hz. So we'll find kp. Kp is 1 by 6 now. So let frequency multiplication factor be n. So now determine the required frequency multiplication factor. We have to find the required frequency multiplication factor. So let required frequency multiplication factor is equal to 1. Okay. That is given as 1. That is taken as n here. Sorry. That we can take it as a n. And the resulting frequency deviation is 300 Hz. So this is the resulting frequency deviation. So resulting frequency deviation is equal to 300 Hz. So n into kp into am into fm, that is equal to 25 kilohertz. So it is given the maximum frequency deviation of 25 kilohertz. So n we have to find. So in this question, n kp we have found, that is a constant, so that is 1 by 6. Am is also given as unit amplitude, so it will be 1. and the FM value that is given as 300 Hertz. So we will substitute all this value. So that is equal to 25 into 10 to the power of 3. So now we have to find N. So after taking these term to the right hand side, so we will get 1000 by 2. So the value of N is 500. So the resulting frequency deviation is 500. So the correct answer for this question is option number C, that is 500. Now moving on to the next question. Consider a FM signal with frequency deviation delta f. So delta f is given as frequency deviation and modulation index is beta. So the approximate bandwidth of the signal from the Carson's rule is given as. So as we have studied in the lecture, the bandwidth using Carson's rule is equal to 2, 1 plus 1 by beta into delta f. So this formula is very important. And this is useful to finding the bandwidth of the FM signal using Carson's rule. So the option B is the correct solution for this question. We'll move on to the next question. So the next question, it is asking the frequency modulated FM signal with carrier frequency FC is given 3 into 10 to the power of 8. So the carrier frequency of the FM signal is given as 3 into 10 to the power of 8, and the equation of the FM signal is given in this question as 10 into cos of 2 pi FCT plus 6 into cos of 2000 pi t. So this is given in this question. Now we have to find the maximum frequency deviation, that is delta f. So we know the formula of delta f is given as beta into fm. So in this question, beta is the constant term multiplied with this part of the signal. So beta is 6 given here, and the value of fm you can find from this message signal, that is it is given 2 pi fm is equal to 2000 pi. So this pi and pi will get cancelled and we'll get fm as 1000 hertz. So this we can write as 1 kilohertz. So substitute the value of fm as 1 kilohertz, and now finally we get the answer delta f, that is the maximum frequency deviation, that is 6 kilohertz. So the option C is the correct answer for this question. So now moving on to the next question, that is consider the passband signal. Here a passband signal is given, and the signal is given as cos of 2000 pi t, and we have to find the complex pre-envelope of this signal. So the pre-envelope of this signal, like passband signal, is given as xt plus multiplied with the complex term j x cap t. Here x cap t is the Hilbert transform of this signal. So Hilbert transform of cos 2 pi t, that is equal to sine of 2000 pi t. So here x cap t is sine of 2000 pi t. Now substitute this value. So we will get the pre-envelope of this signal, of the passband signal, xt is given as xt plus j into x cap t. So we have found the Hilbert transform, that is x cap t. So just substitute this. So xt is equal to cos of 2000 pi t plus j of sine of 2000 pi t. So we can write this as a complex term e of j to the 2000 pi t. Like anything we can write e to the power of j theta, that is can be written as cos theta plus j sine theta. So this is similar to this term. So here you can see theta is 2000 pi. So we can simply write this as e to the power of j 2000 pi t. So now from the given option, the correct answer is option number D, that is the e to the power of j 2000 pi t. So now we'll solve the ninth question, second last question of this session. So in this question, a frequency modulated FM signal is described as xct is equal to 20 cos 8 pi into 10 to the power of 8t plus half sine 2 into 10 to the power of 3 pi t. So the approximate bandwidth xct we have to find using the Carson's rule. So we have recently seen the formula. The bandwidth of FM signal with Carson rules is given as 2 into beta plus 1 FM. So the bandwidth of FM signal given by Carson's rule is 2 into beta plus 1 into FM. That is the frequency of the message signal. So here beta is this term. So beta is given as 1 by 2. So substitute the value of beta 2 into 1 by 2 plus 1. And FM we can find from here. So it is given 2 into 10 to the power of 3 pi, that is equal to 2 pi FM. So pi and pi will get cancelled and FM will be 10 to the power of 3. So that is equal to 1 kilohertz. So now substitute this. So we will get, sorry, here we have to multiply. So into 1000 hertz. So the answer will be 2 into 1.5 into 1000. So this is the bandwidth of this given signal. So that is equal to 3000 hertz. So that is 3 kilohertz. So the correct answer is option number D, that is given as 3 kilohertz. So now we'll solve the last question of today's lecture. So in this question it is given a given phase modulated signal has maximum frequency deviation of 50 hertz. So delta F, that is the maximum frequency deviation, that is given as 50 hertz. For an input sinusoid of unit amplitude, so AM is equal to 1 and frequency is equal to 120 hertz. Determine the required frequency multiplication factor to produce a maximum frequency. So now the N is the required frequency multiplication factor. To produce a maximum frequency deviation that is equal to 20 kilohertz, when the input sinusoid again has AM is equal to 1 and FM is equal to 240 hertz. So now substitute the value. First we will find delta F is equal to 50 hertz. So we will find Kp. So that delta F is equal to Kp into AM into FM. So Kp into AM is 1 and FM is 120 hertz. So this is given as 50 hertz. So the value of Kp, that is equal to 50 by 120. So that is 5 by 12. So now this Kp is constant for the signal. So again the delta F is given as N into Kp into AM into FM. Let's take this as AM2 FM2, AM2 FM2, delta F2. So that is equal to 20 kilohertz. So N we have to find and Kp is given as 5 by 12, AM2 is again 1 and FM2 is 240 hertz. So that is equal to 20 into 1000 hertz. So value of N is equal to 20 into 1000 divided by 240 into 12 into 5. This 0 and 0 will get cancelled. This will become 12 and this 12 and 12 will get cancelled. So after cancelling it will become 200. So the correct answer for this question is option number B, that is 200. So today we will stop here only, and this video will be uploaded on YouTube. So if you have any difficulty, you can ask in the comment box. There we will be happy to reply your solution. So we'll meet again next weekend on Saturday. So thank you everyone for attending today's lecture. So we have solved 10 questions based on the week 6th of this lecture series for the course of Principles of Communication System. And also this video is recorded and the link will be shared on the NPTEL portal. So the viewer who cannot watch it can watch there. So thank you everyone for attending today's lecture. So the last question we have also solved. So the answer is option number B. Okay, so we'll close the lecture here only. Thank you. Bye bye.